two vectors. Subtraction of two vectors. Again we take the vectors, first vector as A vector and the second vector is B vector. Now in this case we have to subtract these two vectors. So let we have to take A vector minus B vector. This is denoted by R vector dash. The resultant of subtraction is R vector dash. This is equal to A vector minus B vector. Now this can be also written as A vector plus minus of B vector. In this case we are adding minus of B vector to the A vector. Suppose firstly we take the A vector. Negative of B vector is the vector opposite in direction to the B vector but having the same magnitude. Now complete the parallelogram by taking A vector and minus of B vector. This is A vector and the minus of B vector is this one. The vector A vector and B vector give the direction along the clockwise direction, and the third side gives us the value of resultant R dash, which is equal to A vector minus B vector. The direction of R dash is along this arrow head. This is in the opposite direction, which is anti-clockwise. So this is the resultant of both the vectors. R dash is equal to, magnitude of R dash is equal to A square plus minus of B square plus 2 A into minus of B. The angle between A and B is theta, so we take a cos of theta and its under root. This is equal to A square plus B square minus 2AB cos of theta. So this is the subtraction of two vectors. If we have to take B vector minus A vector, let us, this is equal to R double dash vector. This can be written as B vector plus minus of A vector. The vector A is this one and vector B is this one. The angle is theta. In this case we take the negative of vector A minus A vector and we add B vector and minus of A vector. Firstly we take B vector and place minus of A vector on B vector and complete the triangle. This gives us the direction of R double dash, which is equal to B vector minus A vector. So this is a R double dash vector and its magnitude is equal to B square plus A square minus 2AB cos of theta under root. So in this case we can subtract two vectors. Next is the multiplication of two vectors. Next is multiplication of two vectors. Suppose we have two scalar numbers, let 1 into 2. If we multiply 1 into 2, the result is 2. 2 into 3 is equal to 6. Means if we multiply two scalar quantities or numbers, we get the resultant which quantity as a scalar quantity. Suppose we multiply a number 2 by a vector which is p vector. This will give us another vector quantity, means r vector is equal to n into p vector. N is any number 1, 2, 3, 4 and so on. So a vector quantity when multiplied by a scalar gives us a vector quantity. Now let us multiply two vector quantities. We have two vector quantities. If we take their dot product or scalar product, we get the resultant quantity as scalar. But if we take their vector product or cross product, the resultant is a vector quantity. Now we will explain the dot or scalar product of two vectors. Let us suppose we have two vectors. This is p vector and another vector is q vector, and the angle between both is theta. Now the dot product p vector dot q vector can be written as the magnitude of vector p, which is p, and magnitude of q vector q into cos of angle between both, cos theta. Now this p is a scalar quantity, q is also a scalar quantity, cos theta is also a scalar quantity. So we get the total result as a scalar quantity. So when we multiply two vector quantities and take their scalar product, then the resultant is a scalar. For example, the examples of scalar product are work done. W is the scalar product of two quantities F and S. F is a force vector and S is displacement, and so F work done is equal to Fs into cos theta. This is the first example, and the second example is the power. Power is given as force vector dot velocity vector. This can be taken as Fv cos of theta. So this is the dot product. Now we take the properties of scalar product. First is it obeys commutative law, means let we take these are two vectors p and q, and theta is the angle. If we take p dot q, it is equal to p q into cos of theta. If we take q dot p, this can be taken as q into p into cos of theta. We see that these two quantities are equal to each other, so we can write p dot q is equal to q dot p, which means the dot product commutes, it obeys the commutative law. The second property is it obeys distributive law. Suppose we have three vectors P, Q and R. Let us add these two vectors Q and R and then take their dot product with the P vector. This is equal to P vector dot Q vector plus P vector dot R vector. So, dot product obeys the distributive law. Now, the third property is the dot product of a vector with itself is equal to the square of its magnitude. Suppose we take P vector dot P vector, this will be equal to P into P into cos of 0 degree. As P vector and P vector are parallel to each other or along the same line, so theta is 0 degree, cos 0 is equal to 1, so this is equal to P square. Then next is the dot product of two parallel vectors is product of their magnitudes. Suppose we have P and Q vector and we take their product dot product, which is equal to P into Q into cos theta. Let theta, if theta is equal to 0 degree in case of parallel vectors, then cos 0 is 1 and we get P into Q. So, dot product is equal to product of magnitudes of two vectors. The next property is the product of two perpendicular vectors. The dot product of two perpendicular vectors is 0. P vector dot Q vector is equal to PQ into cos 90 degree. If two vectors are perpendicular, theta is 90 degree and cos 90 is 0. So, PQ into 0. So, we get resultant is equal to 0. If we take the dot product of I into I, J into J and K into K, unit vectors I, J, K, as we have stated earlier, I cap is unit vector along x axis, J cap along y axis and K cap along z axis. Their dot product is always equal to 1. I dot j is equal to j dot I is equal to I dot k is equal to k dot I is equal to j cap dot k cap. is equal to k cap dot j cap. All these products are equal to 0. Let we have two vectors p and q. P vector is equal to px I cap plus py j cap plus pz k cap. Q vector is equal to qx I cap plus qy j cap and qz k cap. P dot q is equal to px qx plus py qy plus pz qz. So these are the few properties of the dot product. Now we take the second product, which is called vector or cross product of two vectors. Again we have two vectors. Let us, this is equal to p vector, this is q vector. Theta is the angle between these two vectors. If we take p vector cross q vector, we take the cross product of these vectors. This will be equal to p into q into sine of theta and a unit vector n cap, which is perpendicular to both p as well as q. The result of p cross q is equal to t vector. The t vector is perpendicular to both p and q. The direction of t vector is given by right hand thumb rule. If we have to take p into q, curl our fingers from p to q, the direction of thumb gives the direction of t vector. N cap is a unit vector along t vector. If we have to take q vector cross p vector, this will be equal to q into p into sine of theta into minus n cap. This will be opposite to the t cap, so the vector will be equal to t cap. This will be minus t cap. This is the vector or cross product. The examples of cross product is, first is the L vector is equal to R vector cross P vector. L is angular momentum, which is equal to perpendicular distance R cross linear momentum vector. The second example is torque vector is equal to R vector cross F vector. R is the perpendicular distance and F is the force vector. So these are the examples of cross product. Now we take the properties of cross product. First property is it obeys distributive law. If we take three vectors p, q and r, we add q and r vector and take their cross product with the first vector p. This will be taken as p into q, p cross q plus p vector cross r vector. This is known as distributive law. Second is the cross product does not obey commutative law. Means p vector cross q vector is not equal to q vector cross p vector. The directions of both these products are opposite. This has been stated earlier, but the magnitude of these products are equal and these obey the commutative law. Now the third property is the cross product of a vector with itself is 0. If we take p cross p vector cross p vector, this will be equal to p into sine of 0 degree and a unit vector n gap. Sine 0 is 0, so this is equal to 0. So cross product of vector with itself is always 0. Now the next property is the cross product of two parallel or anti-parallel vectors is 0. Suppose we have two vectors p and q. Angle between them is either 0 degree or 180 degree. Then PQ into sine 0 degree and n cap, this will be equal to 0. If two vectors are parallel, then product will be equal to 0. And if they are anti-parallel, theta is 180 degree, then the product is also 0. The next property is the cross product of two perpendicular vectors is maximum. Let we have p vector and q vector and they are perpendicular to each other. P cross q is equal to p into q into sine of 90 degree into n cap. Sine 90 degree is equal to 1, so we take this is equal to p into q into n cap. The next property is the cross product of I into I, j cross j and k cross k is equal to 0, but I cross j is equal to k cap, j cross I is equal to minus k cap, j cross k is equal to I cap, k cross j is equal to minus I cap, k cross I cap is equal to j cap, I cross k is equal to minus j cap. This we have to remember. Next is if we have two vectors p and q, p vector is equal to pxi plus pyj cap plus pz k cap and q vector is equal to qxi plus qy j plus qz k cap. If we take their cross product, this can be written as modulus of I, j and k px, py, pz, qx, qy and qz. This is equal to the mod of I cap is equal to py qz minus pz qy plus j cap qx into pz minus px into qz plus k cap px into qy minus qx into py. So in this way we can take the cross product of two vectors p and q. The next property is the by this vector product we can find the area of a triangle. Suppose we have a triangle whose two sides are p vector and q vector. This is the third side. Then the area of this triangle can be given by half of p vector cross q vector and its magnitude. Similarly, we can find the area of parallelogram. If we have a parallelogram represented by p vector and q vector, these are the opposite sides, then the area of this parallelogram is equal to p vector cross q vector and its magnitude. So these are the properties of the cross product. Hope you have understood this topic, and thanks.